All right, quadrilaterals day one. With this section, it's just going through all the different types of quadrilaterals you guys will work with. You probably know a lot of them, but we're going to define them in a way that'll help us throughout the chapter. Okay, first off, a parallelogram is a quadrilateral with opposite sides parallel. Remember, when we say quadrilateral, we mean four sides. And when I look at this, we have one pair of opposite sides parallel, then we have a second pair of opposite sides parallel. Okay, then we have a rhombus. A rhombus is basically a parallelogram with four congruent sides. So not only do we have opposite sides parallel, but we can also mark the opposite sides. These sides are congruent to each other, and these sides are congruent to each other. So all four sides are congruent. Okay, the next one, a rectangle. When we talk about a rectangle, right, it's a parallelogram because opposite sides are parallel, but it has four right angles. Okay, and then a square is basically a rectangle, but not only is it a rectangle, but all four sides are congruent. Okay, remember you can always pause the video to write stuff down. A kite is a quadrilateral with two pairs of congruent adjacent sides. So when I look at it, I'm going to say these sides are congruent and these sides are congruent. This makes a kite because these adjacent sides are congruent and these adjacent sides are congruent. Okay, a trapezoid is a quadrilateral with one pair of parallel sides. So right now we can say those sides are parallel. Now, one thing about this is these are the bases of the trapezoid, and these are what we call the legs. So the bases are the parallel sides, the legs are the non-parallel sides. And the last one, isosceles trapezoid is basically a trapezoid with congruent legs. So we know we have our one pair of parallel sides, but then we also know that these legs will be congruent. So how can we use these definitions to go ahead and answer questions? Well, before we could do this, let's talk about this real quick. If we had to define the opposite angles of quadrilateral and identify the pairs in a diagram, opposite angles are basically non-adjacent angles. When I look at A and D, these are adjacent because they're next door to each other. When we say opposite, B and D are opposites. So angle B and angle D. Then I also look, angle A and angle C would be a pair of opposites. Okay? If we had to define opposite sides, right? They're basically the non-adjacent sides or the sides that do not intersect, right? So when I look, what would be opposite of AD? That would be BC, okay? What would be another pair of opposite sides? AB and CD, okay? Now, define adjacent angles of a quadrilateral. If I talk about adjacent angles, these are basically what I like to call the neighboring angles, right? So when I talk about a neighbor, it's like going next door, right? So they're basically the opposite of opposite angles, right? So we would say angle A and angle B would be neighbor or adjacent angles. Angle B and angle C would be adjacent angles. Angle C and angle D. And then finally angle A and angle D. Okay, those would be your pairs of adjacent angles. Now, adjacent sides are basically the sides that intersect. So when I look at adjacent sides, AD, right, and AB, would be adjacent sides. AB would also be adjacent to BC. Then BC would also be adjacent to CD. And finally, CD would be adjacent to AD. All right. And if we had to define and construct diagonals, to define it, right, diagonal is a segment whose endpoints are the opposite vertices in a quadrilateral. Okay, so when I look here, if I connect these opposite vertices, almost like the opposite angles, B and D, right? BD would be a diagonal, right? And my other diagonal would be connecting A and C. Okay, so AC would be the other diagonal. All right, so how do we put this all into play? So number one, find the values of the variables for the kite. For this kite, remember, you have two pairs of non-adjacent sides congruent. Normally, we don't assume by the diagram, but in this case, we can. And when I look, right, we know JT is congruent to TK. So to find X, right, what I'm going to do is basically set those equal to each other. But if I look, I have an X and a Y. So if I look, I also know that JB is congruent to BK. So when I set these measures equal to each other, now I can go ahead and solve for X. So I subtract 3X, subtract 4, negative 1X equals negative 9, so X equals 9. Once I have X is 9, now I'm going to plug that value in up here. 2y plus 5 is equal to 9 plus 6. So 2y equals 15 minus 5 is 10. When I divide by 2, y is equal to 5. So this is using the basically the definition of a kite to find the value of the variables. So the next one, find the value of the variables for the rhombus, then find the lengths of the sides. Well, if I know what the definition of rhombus is, I know that all four sides are congruent. If all four sides are congruent, I'm basically going to set the sides with the congruent variables, or the same variable. So I know that these sides are congruent, so I can set 5a plus 4 equal to 3a plus 8. When I go to solve this, 2a equals 4, a is equal to 2. Now here's the thing. Realistically, I can go and find the length of all the sides now if I wanted to, because 5 times 2 plus 4, that would give me 10 plus 4, which is 14. Well, that tells me all of these sides would have a length of 14. But it wants the value of all the variables, right? So I still have to find B. So I know these sides are congruent also. So 4b minus 2 is equal to 3b plus 2. When I solve this, b is equal to 4. All right. Number 3. Since we have an isosceles trapezoid, I know opposite sides are parallel, but the legs of this is congruent. So if I wanted to find x, I'm going to use 2x plus 2 is equal to 4. When I solve this, 2x equals 2, x is equal to 1. Now if I want to find the length of each side, this side would have a length of 2, right? This side would have a length of 7, and then this side would have a length of 4. Okay, so again, we're using the definition of what an isosceles trapezoid is to find the value of x and find the length of each side. All right, the next one. I know this is square, so I know all four sides are congruent. So the first thing we're going to do is take any two sides and set them equal to each other. So does it matter which one you use? No, I'll use these sides. 2y minus 5 equals y minus 1. When I subtract y, I get y. When I add 5, I get 4. So right away, I know y is equal to 4. So how do I find x then? Well, if I plug 4 back in, 4 minus 1 gives me 3. So I know the length of this side is 3 because all four sides are congruent. So 2x minus 7 equals 3. 2x equals 10. X is equal to 5. Okay, go ahead and try the homework and let me know if you have any questions.